week 7, lecture 14, Energy Y 102. Let's just take a peek at the syllabus here. Also want to let you know I will not be in town next week, but Tim's going to give a lecture. Leave you in his capable hands. Okay, so we've covered chapter 4, so we're kind of ahead of the game on that. I've got summary 3 due next week. We'll get as far into it as we can. A lot of times, if you took 101, which you did, it should not take as long to do in a 101. There's a couple other little tricks and twists in there, but if you saved your data from last semester, you'll be able to hop right through it, and I'll show you the other little bell and whistle I want to add. So just as a Excel refresher, I'm going to go through a project that we just did, or a problem that we just did in 101, and I'll kind of overview it. So we've got some initial data that we're working with, and that's the fact that in 2013, the United States produced 2,720,782,000 barrels of crude oil. In that same year, we imported 3,598,454,000 barrels, and we consumed 134,506,764,000,000 gallons of gasoline. So the question that we're being asked to solve is, how much gasoline did we use from imported crude? And we're gonna work with the assumption that in a single barrel of oil, we can make 42 gallons of fuel total. Of those 42 gallons, 12 of them are going to be diesel, 20 are going to be gasoline, 10 are going to be, what did I put heavy? Oh, I got heavy G. I meant to say heavy HC, heavy crude, and light N. So longer chain molecules than the octane and the diesel. We can also express those as fractions or percentages. The numbers that you see here, that's just the number 12 divided by the number 42. And we can come down, maybe make those a little easier to work on. I just hit the Control 1 button. If you recall, typically we only need like 3 significant digits. Beyond that, the rest are somewhat arbitrary and not unnecessary. So I'll change that to 3 sig digs. It's just a little easier to read. As a double check, you can come in and say equals the sum of these 3 numbers, close paren, make sure that everything adds up to 1. It's just good accounting practices in general. I also put in a little conversion table up here. As you can see, I used yellow for input cells. So let's say 100 gallons of gasoline. That green barrels column is going to update and tell me how many barrels that is. I could do the same thing if I've got 500 barrels. They'll tell me how many gallons. I could even sort of cheat here and say this cell equals that number. I can just use Excel that way, and that'll tell me, okay, that's how many gallons I have. So there's a bunch of different ways to use this thing. Play around with it. It's handy. Nice thing about the spreadsheet is once you've got that model set up, it's yours to keep. Play with. Okay, so again, yellow's input, green is calculation, and then the blue boxes are the output. So again, let's look at the data we have. There's our imported crude at the top, 2.7 billion, production's at the top, 2.7 billion. Imported is next, 3.6 billion barrels. And you'll also note that I've done myself the favor of putting in parens the units. You know, it's important. You go back, like, what the heck unit? Well, tell yourself what units you're using, put it in parens, that way you'll remember. And then when you see this number, oh, it's a much larger number. Why is that? Well, it's gallons, and we got that 42 to 1 ratio. So another little double check on that. Now, the first question asks, how much U.S. gasoline was used from imported crude? And to do that, there's a couple ways to do it. One kind of slick way that we went about it was to say, well, if this is the total import here, and we know that of a barrel of gasoline, about 47%, 48% is, of a barrel, 47% is turned into gasoline. Click in this little box, we can see that we take the total, multiply it by the fraction, and there's your answer in barrels. And let me make that, I'm going to make that a green box since it's calculation. Okay, and then it's as simple now as just converting that to gallons. Another little thing you might try here. One thing I'm questioning about how I did this last time, I never actually put the number 42 in, and that's one thing I might do here. So gal per barrel, if you put 42 here, this can be, you could use even a different cell color, like a constant. So like, if you had gravity in there, for example, or pounds to any conversion you might put as a...
red for constants.
Okay, that's fine. Is that a Fraser convention?
Yeah.
Yeah. So we'll just...
You guys will see this all on 214 when you're spreadsheeted to death.
So we'll do that. And that's kind of nice to see, because one thing I did not do, and it's nicer not to, see I've got that number 42 kind of buried in the formula. It's usually nicer to yourself to just have those numbers elsewhere. So in your formula, you just have references to cell and operators and not numbers buried. So you might even somewhere else in your sheet have the number pi, for example. So I'm just going to go ahead and do that now. I'll kill that.
Remember when I showed you how to do word problems at the very beginning, week 1, pull out your data and make your data table?
Mm-hmm.
It's easiest to do that in Excel of any number that you know that you're going to use right off the bat. Just put it in that table so you can reference it over and over again.
Yeah, there you go. So now you can click in this guy and say, okay, where the heck did that number come from? Well, it's the product of the number of barrels and the number of gallons per barrel. Okay, and then in terms of percentage, let's hold off on this for a second because the formula is kind of complicated. So at least we know how much gasoline came from imported crude. Is that, gosh, what is that now? For some reason, 72 seems like it's more than 42 times greater than 1.7, but I guess the computer can't lie, so.
That's what I got.
Yeah, okay, all right, good. All right, so now let's now ask how many gallons came from the U.S. production rather than from crude. So right down here, what we've done is multiplied the U.S. production, which is in B3, by the fraction of that that's converted into gasoline, or sorry, yeah, into gasoline. We'll just use that 47.6%. And you just inspect those numbers, say, okay, 1.3 is about, a little less than half of 2.7. That looks good. Again, this guy, I'm going to go ahead and do that same conversion we did above, times, dink, enter. And so now we know the gallons produced from U.S. production. We know the gallons produced from import, And now the question is, how much came from imported? And you hear people talk about energy security all the time. So one would think that the larger that number is, the less secure our energy supply is, more or less. That's kind of the way to think about it. The closer you can get that to zero, the more independent we are and the more energy secure we are. So 56.9, where did that come from? Well, in the numerator, we've got the imported number, so B9 is on the top, and then the total is on the bottom. So it's what we imported plus what we made domestically, and there's the 56%. You can see that the imports were greater than the domestic production, so therefore the number's more than half. Yeah.
The mistake I made this morning as I was doing this problem, keep in mind, my first thought was, oh, what percentage is that of 134 billion? Problem is, if you add up what was done imported and what was done from domestic, they don't add up to 134 billion. They add up to 127 point something billion. So somewhere we've got to account for, and you'll see that number down there at the bottom. Well, no, that's the unrefined at the bottom.
Barrels, yeah.
Somewhere I got to account for 7 billion barrels of, or gallons of gasoline, and where did it come from? So that's why it's critical that you use that formula that Brad used there versus just using the standard number given on top, because you have to double check yourself to make sure those add up. If they don't, your percentages are going to be off by quite a bit.
Okay. And then how many barrels were required for our gasoline consumption? So in cell B5 is the consumption. So to do that, we went ahead and looked at, let's click into here. So if you double click, it'll show you. So there's the total, 134 billion gallons, and when you divide that by 20, that's more or less how many gallons of gasoline you're getting out per barrel.
And I would change that to a cell number.
Oh,
because
yeah.
Sometimes if you have a different value, say it's Brent crude versus Saudi Arabian crude, you
Yeah.
have different values of what comes out of there. So in order to, if I want to change the values of my table, it'll automatically change that equation as well.
Yeah, let's go ahead and do that. And we can just pop a whole new row in up here. Doesn't change the formula at all. We can say gas per barrel 20. Go ahead and use the same convention as red that we used before. Center that up so it's tidier. Dink, 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 dink. There we go. And now you can double click that, see, okay, where'd that come from? Boom. Okay, now what we're looking for next is the discrepancy. So right here, this number is the total production and imports at 6.3 billion, but we actually required more. So there is a difference. And so where did it come from? I mean, do you know? I mean, I don't.
Yeah, it is.
Yeah.
It actually comes from the fact that we do import pure gasoline that's already been refined. So that discrepancy of 406 million gallons or barrels? Barrels, I think.
Yeah, let's see, barrels, yep.
So that discrepancy of 400 million barrels is actually just because it was refined somewhere else and came in here. Because these other two are assumptions that I took every bit of U.S. oil production and made gasoline with it. And I took every bit of the imports and made gasoline with it. And we all know that that's not really the mix. And also the 20 gallons per barrel is purely a kind of a international standard agreed upon, just like coal is. We agree coal is 28 megajoules per kilogram, even though we know that the actual spread is anywhere from 10 megajoules to 32 megajoules per kilogram. So it's just using an international standard, assuming everything is the same there are some assumptions here, but even then, the numbers don't add up, and it's kind of throws you for a loop, but it shows you why the math is so critical in making sure you're using the right numbers, not to add up to what that total says, but to add up, so you're actually comparing like numbers.
Okay, so just a little warm-up problem, using a little bit of Microsoft Excel. Now, let's go back here. I'll take a quick break, and we'll hop into summary 3, and then we'll finish up today. I'll get as far as I can in the hydro chapter, and I'll let Tim take it from there. And I will answer your question, Shauna, about the pasting figures into Microsoft Word.